Hello, we're Team Tiny. My name is Jun. I'm the producer and UX designer.
I'm Shreya. I'm the producer and 2D artist.
I'm Carl, the programmer.
I'm Gibran, the game designer.
And our instructors are Ricardo and Scott. So for this project, our clients are Intermediate Unit 1 Colonial School. The target audience are students from grade 4 to 6, aging from 9 to 11. They need to learn about angles, but they were having difficulty understand this abstract concept. So our goal is to teach about angles and motivate the student by providing them a fun and engaging iPad game. The final deliverable will be a finished IPA file pushed to the clients. Now Gibran will talk about the game design.
So let's have a look at a snapshot of gameplay. First, a user would be presented with a map, which they'd select the level they want to play. In that, they would see the main mechanic of our game. Using numeric representations of angles, they would create a spatial representation in order to solve a puzzle. As you see, it involves pointing a beam of light towards an objective. The player then completes the level and then goes off to receive their reward. In this case, it was a trophy, which we presented in a trophy room. So how did we get here? So at halves, we had our core mechanic, but it required a greater experience to surround it in order to engage our target demographic. So for a source of inspiration to create that experience, we looked at the kind of problems that our target demographic would be looking at in the classroom. These are some of them, looking at complementary angles, supplementary angles, measuring the protractor. We used that as a source of inspiration in our design process. So we started with the beam maker. That was the main mechanic of our game, which could already represent some of the problems, but it needed more in order to make an engaging experience for our target demographic. So we introduced an objective, a goal for our players. Next, we introduced a larger problem space in each of the beam makers so we could create more interesting kind of problems to consider. Then we introduced new problem spaces to increase the complexity of the puzzles. At that point, we only had anti-clockwise gems. We saw this as an opportunity to introduce a new notion to our target demographic in the form of negative angles, clockwise rotation. And lastly, we came across, in Common Core, a number of geometric problems. We figured, how could we create these for our target demographic? So we introduced obstacles and beam receivers. This also increased the complexity of the problems we were looking at. Next, we considered, well, would our puzzle be intrinsically motivating enough? Well, we weren't sure about this. So we created additional sources of motivation. One was this character, you see. Characters are commonly used in educational experiences, and there is evidence to suggest the benefits of their use. So we considered it a method to augment the learning in our experience. Next, we looked to fulfill the expectation of rewards that we were creating with the treasures. So we created what we called was the cabin. The cabin would contain the rewards of our experience and would not only, we hoped, reinforce a motivation to collect, but also act as a measure of progress in the experience. So with these fundamental elements, we went back and we went and crafted the core content of our game, which would be the puzzles. Using our sources of inspiration, we started designing puzzles, but it was not as structured as we would like. So we turned to a design tool to complement our process. This design tool we used to incrementally increase the complexity of puzzles using the game elements as metrics of puzzle complexity. Playtesting, though, revealed we needed deeper analysis of this. So we looked at each of the elements more closely, in particular, the angle values that we used. This allowed us to refine the experience we were presenting. So next, we also consider the rewards within our experience. As you can see from the number line, these are intervals where we place trophies at the highest points of difficulty in order to properly reward our players. In between that, we also intersperse treasure, which we hoped act as elements of surprise between levels. So how did that all fit together? Well, I think it can be best exemplified by the following graph. This is a graph of the number of gems against the number of levels throughout the experience. As you can see, the complexity of puzzles are increasing over time. And if you notice, there are a number of dips which commonly correspond to the introduction of gameplay elements that I'd mentioned before. Now, what was this complexity serving? Well, in the beginning of the experience, we would allow for brute force to be rewarded. But as complexity increased, we would naturally incentivize more logical thinking in this matter. With this complexity design, we also hope to create natural, skill-appropriate teachable moments, which teachers could capitalize on as students reach the boundary between brute force and logical gameplay strategies. So enough about design. I'll hand it over to Len, and now we'll talk about the art side of our experience.
Thank you. After half, we actually changed our star scene and also our game name. We have a new game name, Angle Jungle, which is more theming and suitable for our goal. We also add different elements like the animals into the star scene because we now have 5 different themes. And initially, we have very simple user interface design. After half, we change it into a more funny way to express. We now can choose the blue buttons to choose the level they want to play, and they can also get access to the trophy room to see what trophy they already have by clicking the orange button in front of the ship. And we also add the treasure button and map button into screens. They can click the treasure button to check what trophy they already have, and they can also choose each level they want to play by clicking the map button. Based on our character concept design, we developed several animations according to our game. And we also develop our art assets to make it look more cartoonic style. We develop our angle gem into 2 different colors. The red one represents the negative angle, while the blue one represents the positive angle. We also change our protractor tool into a more magical style. After several playtests, we noticed that the players, they turn more likely to use the new protractor tool because they think it was more funny. We develop our trophy room. We now have 6 different slots. So in the beginning of the game, the players can get to know how many trophies they need to gather in the whole game. And they can also gather the treasure. You can see in the corner, the treasure box are increasing while you're playing the game, which can motivate them a lot. We also develop our scenery. We now have 5 different scenery: the Jungle Island, Monkey Island, Lake District, Tropical Island, and Forest. We now make it diversity and interesting so that the players cannot feel bored while playing the entire 30 levels.
Initially, our objective from clients is pretty vague. First is to create an experience with angles, and the second is to integrate the protractor tool in some manner. Finally, we got a very clear primary learning goal. It's split into two. One is transformation, one is activity. We showed the game to some researchers like children's psychologist in CMU, Sharon Carver. She saw the game mechanics are pretty good, and the protractor tool would definitely be worth testing. And we also got a very clear secondary learning goal, is to introduce, build familiarity with protractor tool, to introduce positive and negative angles, introduce angles that greater than 180 degrees. During the last half of the semester, we were playing with game mechanics like multiple beams, beam receivers, gem swapping, obstacles. They are all serving for game design. So designers can design based on what mechanics we have, and mechanics can build based on the requirement of design. During the whole semester, we got more than 60 builds. So the technical breakthroughs and iterations, they are proceeding simultaneously. In this way, whenever we got a new idea, we can just implement it as soon as possible, so we can play test it quickly to see if it works or not. Now, Jun will introduce something after soft and play testing.
Okay, thanks, Carl. So over the soft opening, many faculty pointed out that the winning game waiting time was too long after clearing a level, because many of the students have very short attention span. We fixed this issue by shortening the waiting time from 5 seconds to 3 seconds in order to optimize the gaming experience. And then, over the course of the semester, we have done playtests over at these 3 schools, as well as ETC on playtest days. We have run more than 10 playtest sessions, and then more than 60 individual students participate these sessions. During playtest, we noticed that students were able to utilize protractor tool to help them estimate angles. They were able to calculate angle values, and they also asked for help from their peers or teachers. They also collaborated with each other to solve puzzles. And the most important thing is they told us they really liked the game. The teachers told us they would like to have this game as an in-class supplement to their existing curriculum. And they will also to use this to form a friendly competition among students and encourage them to play, to get more knowledge and know more about this subject. They will also like to use this game as homework assignments to reinforce the class, the lessons in class. Based on the feedback we received, overall the feedback is really positive from both the target audience and the clients, which is one of our goals to measure success. In addition, we incorporate the gaming experience with teaching abstract angle concepts. Last but not least, we manage the production schedule and deliver the file to the clients. So the lessons we learned: first, define reasonable scope. We didn't change the game mechanics after halves. We carefully craft the 30 levels with a smooth learning curve. We only added essential features that could enhance the gameplay, such as the trophy room, as well as the map UI for level selection. In addition, we learned that reach out to researchers and professionals is very helpful. They provided us with valuable insights that we never thought about. And last but not least, playtest as much as possible. Since we run so many playtests, we learn our target audience very well. We know what they like and we know what they don't like. We continually refining the game over so many iterations, and now we are able to make a game that they like and the game is useful to them. And we also went beyond our scope a little bit. 2 weeks ago, we submitted this game to the App Store, and surprise, we got approved within 24 hours. We didn't really do any promotion, but now we have over 160 downloads, 10 ratings, and 4 5-star reviews. And for future plans, we're planning to promote this game and apply it to different competitions and conferences. And special thanks to Daniel Cohen for making all the sound assets for this game. He's very busy, I know. Yeah. And special thanks to the ETC faculty and our peers for their help and feedback. And special thanks to all these J people again and the schools. So we're Team Tiny. We make Angle Jungle for students from grade 4 to 6, teaching angles to them. Thank you, and we're now open to questions.